Hello everyone. Let's discuss one more problem. Molecular weight 70, UV lambda max 285 nanometer epsilon, which is intensity of the UV band is 23, two IR bands 3060 and 1785, two NMR signals, triplet. Be careful here, tau value is given instead of delta. So we have to convert it into delta by subtracting from the 10. Reason is that sum of delta and tau is always 10. Tau 8.4 and 8.9 square. Second signal quintet, tau 8.8, 4.5 square. So immediately before we start solving problem, we are getting these informations. Molecular weight is a 70, which is lesser than 75, 76, 77. So we can say that compound is not aromatic because mono substituted is 77, di substituted ring is 76. That's why. Very important triplet quintet combination in NMR, that is indicating X CH2 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 X group. Let me tell you friends, here my meaning is X is not halogen, but X means with both terminal carbons same group is attached, and that's why in NMR they are same. That's the meaning. Okay, from IR 1785 carbonyl group is present, so its weight is a 28, and this we already discussed. Values are given in tau, so we have to turn it into delta. Now let us solve the problem. UV is 285 nanometer lambda and 23 epsilon. Epsilon normally lesser than 100, indicating N to pi star transition. And N to pi star transition is very common in some functional groups like carbonyl. So IR also supporting the data given into the UV. Now let us discuss the IR. First band is 3060. You will find that value in aromatic stretching. But as I said, that is not possible. Also alkene stretching. In my previous presentation also I informed you that sometimes IR values are sometimes differ than the data. So always we should derive the structure according to other proof also. Okay, now let us discuss about NMR. So first let us determine the proton ratio of signals. 8.9 square and 4.5, this is a smaller one. So divide by both the signals. If divide, proton ratio of both signals AB is 2 is to 1. When this tau value convert into delta, it is 1.6 and 1.2. Their sum is always 10. You know that in theory. And we already discussed triplet quintet, very important clue, indicating this group, where at both ended carbon, same group is attached. So weight of these three methylene is a 14 each. 14 3s are 42 and carbonyl is 28. So 70 is completed, which is the molecular weight of this problem. So now what to do? Because these two protons are same, and as I said, both must have same group, and only if the part left is a carbonyl. So we cannot put carbonyl here because then the valency of carbon won't, this carbon as well as this carbon won't satisfy, and 70 is actually justified. So friends, to put these groups together is a really tricky issue, because if you think this way, then you cannot simply write here carbonyl, because in that case the valency of this carbon would be not satisfied. So we should think about, and NMR says that these two signals, this particular signal, 4 protons, their triplet, and these two protons, their quintet, and proton ratio is 2 is to 1. So this and this carbon must be equivalent. So instead of linear structure, we should think about cyclic structure. So friends, this is the answer. Now you can see that CH2 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 is this, And instead of two separate group, both terminal carbons are attached to CO group. That's why they are identical. 4H triplet and 2H quintet. And this is a carbonyl group. And name is, this is a cyclobutane parent ring and ketonic group. So the name of this compound is a cyclobutanone. So in this problem, one can easily identify the groups, but to arrange them need practice. So that way this problem is a little bit tricky. I hope that you understand it.